You are live.
Excellent. Hello, everyone, and this is the Tech Talk from Wikimedia Foundation about graphs. Graphs. About a year ago, Dan and a few other people got together at a hackathon and decided that Wikipedia could really use some graphs, and they implemented a very simple testing little project to try to bring a Vega based definition of graphs to Wikipedia. The project was successful at the time, but it needed a lot more work to become productionized. About half a year later, Zero team needed to implement some graphs on wikis, and that's when I discovered the project and began my quest to bring it to Wikipedia's first to Zero Wiki. Being a small wiki, it was much easier, and then to full-scale deployment, which happened a few days ago. So from now, I will switch to my little slides, if I can find them somewhere. They should be. Hello. Graphs. So up to this point, graphs were either done as PNGs or SVGs. So obviously they were not very easy to modify, because once you upload an image to Wikipedia, you're stuck with it. You have to go to the original source of the data, original program, in order to edit and recreate the data and recreate the graph and enter some additional data. So obviously that was not very convenient. Hence, this is the implementation. It consists of graph tag, which includes a graph definition. You can read about it on Vega.js website. It supports Vega.js grammar, which is developed at the University of Washington, and it also supports template parameters, which brings it to the wiki world. Once the definition is resolved, it gets. Sorry, I thought that someone's pinging me. Once the definition gets resolved and becomes a proper graph, it gets stored as page properties, which later gets rendered either on the client side by a Vega.js library. Unfortunately, the process is fairly slow because it requires a large download, but on the other hand, it's much more flexible. Or it can be rendered on the server side. At this point, we have most of the graphs rendered on the server side, except when you're editing and you click page preview. This is an overall schema of how things work. First, let's see if I can get the mouse on. The wiki markup contains the definition. From in there, the parser puts it in page properties and also into HTML. HTML gets updated only for the page preview, whereas page properties get updated all the time. So HTML gets sent to the modern browser, which uses the JavaScript libraries to render it. The page properties, on the other hand, get used by the Graphoid service, right there, that second block on the right, middle block on the right. That's the service that pulls the data and renders it into a PNG or later as SVG. Now, Vega. Vega is a fairly complicated grammar. I tried and I failed to become fully proficient with it, but there's a potential. The problem with Vega is its complexity. The beauty of Vega is its power. It can express pretty much any graph data you can possibly throw at it. So there are some additional tools coming out that I think Dan will talk about a bit later in this presentation to make it much, much simpler. So there is data sources that you can either embed the data inside the definition or you can reference it as an external data. Then it becomes a transformation system. It uses transformation where it can transform that data using either JavaScript expressions, or it can do various data manipulations like zipping two data sources together, filtering. It can do cross-product. It can do grouping and many other things. And it can do visual encode transformation. That's where it prepares data for visualization. It can do, because graphs can do maps being just another set of data, it can do geo-encoding, geo-transformation, it can do pipe preparation, it can do the things like if you have a stacked graph to calculate where each point should be drawn. Lastly, there's two more aspects. There's scales. The scales is an important concept there. Once you have the data needs to be spread across the axes. You can think of it as a projection. You have the data on y-axis, for example, and then you have the scaler that looks at that data and says, oh, so this is the little transformation it should go through in order to become the actual pixel on the screen. There's marks, which is where you say how the data should be drawn. Should it be a line? Should it be a shaded area? Should it be bars or stacked areas or many other things? Now, for the fun thing. There is the simple way to use graphs, which is to embed data directly. You just say values and you specify the values in JSON, directly in the JSON format. Or you can set it up as an external URL where you can actually pull an action raw content of some other page or even API call. There's more fun things like template parameters, where you can just say either a named parameter or there's a default value, or you can actually use much more complicated parameters there, where you can use MediaWiki expressions that expand into parameters. And lastly, something that I recently started using, which is a Lua module that can prepare the data and embed it right there in the graph. So you basically use the data embedded directly method, except that it's a template that uses Lua module to expand to create that data on the fly, and that data actually gets pulled from another page, for example, or multiple pages, gets combined in Lua, and Lua just gives you the final result. I'll show you a demo of that momentarily. Demo. Okay, let me first of all switch to check that there is no questions so far. Other questions? Has anyone been asking any questions?
Yep, there's one question, Yuri. It's the docs mentioned that the ability to do word clouds, but I couldn't make it work. Does Yuri know if that's supported?
Yes, word cloud. I know that word cloud is not enabled yet. That's because word cloud requires an additional library that wasn't part of the initial deployment, and I need to put it through the regular security checks and other things like that. Once it goes through, it should be fairly easy and quick. I'll deploy it everywhere. Any other questions so far?
Nope, that's it so far, unless anybody in here has anything. Nope, go ahead.
I'm good. All right. Screen sharing again. All right. Ta-da. Now, right underneath the expression graph page, there's a demo page, which has all my current little toys that I've played with. So I'll start at the bottom because that's actually the simplest graphs. This is the absolute most simple graph you can come up with. It was taken directly from Vega examples. There's no external data, there's nothing, and actually I copy-pasted the actual definition of the graph here as well. So there's some basic setup parameters like width and padding. There is the data source, which is embedded right there into the system, into the definition. There's scales, which explains how the x and y coordinates should be worked on. Also defines the axes, which is very simple and straightforward, and the marks, which says that the type of mark should be a rectangle, and sets up where the x and y and width and height should go. plus the color of the graph. If you click on edit source here and you go to page show preview, you'll see that the graph actually becomes live. That's because at this point, and it might change in the future, this gets rendered locally as opposed to by the Graphoid service. Leave this page. We're not gonna edit this now. Okay. Now next, next graph from the bottom is slightly more complex one. This is the simple graph defined in graph examples template, and it takes one parameter, which is the color of this graph, and you can click on it, and there it is, and we can edit source again. This time it's an arc graph. Again, the data is embedded. There's a simple transformation to allow pie chart drawing, and basically the only exception to the previous, the only difference from the previous graph is now it's a template parameter expansion, which either uses the CCC color or the first parameter. Simple, not very exciting. Moving forward, now this will become possible if we ever allow for the proper API calls inside either Lua or some other method.
Yes, you had a question?
Yes.
So
1 second. There we go. Yes.
That example, the reason that doesn't have a graph tag around it because it's in that special graph namespace. So I'm wondering, are we going to configure a graph namespace on every wiki so that if you just put JSON in it, it'll say, oh, this must be a graph? And if you don't do that, where do you put the JSON file? See if you don't want to like fill up every page with big chunks of JSON.
That's a great question. On 0, we had graph namespaces initially. That's how I envisioned graph namespace to be the primary way of doing it, and the graph tag was added as an afterthought. But the more I experimented with it, the less I like the graph namespace idea. And the reason for it is because graph namespace is JSON, strict JSON, whereas graphs mostly useful as templates, as I will demonstrate in a second. So having a separate namespace just for graphs without actually any benefit from the syntax processing becomes fairly pointless. What I found the most useful, on the other hand, is to store graphs as their own templates, because they are just as easy to embed. You just do two figure brackets and you put the name of the template in, except that now it falls into a general concept of parameter expansion. I mean, all the benefits of the templates. Yes. Because of that, I've decided that graph namespace is more of a hindrance than a benefit. It's better to put these graphs as their own templates wrapped around by the simple graph tag. And if you ever need to put some additional things that cannot be expressed by graph, like a little header or a title right above it, it still would fit in perfectly inside of that template. Hope that answers the question. And switching right back to So this is the API results. Here I try to show the contributions by the users, who basically a way to engage authors, editors, in the sense that give more credit to the editors. The first graph is, but after some filtering, the edits of Barack Obama article. with basically with each user being with the edits being stacked one on top of the other to signify the addition of the article size or decrease in the article size. So this shows the top 20 of the editors. And this is a different one. This is Douglas Adams' article. This one is the just absolute contribution by who made the biggest contribution. By the way, that spike was due to Google running a Google Doodle about Douglas Adams. And now I move to the coolest, in my opinion, graphs that use geographical data. So I took world definition JSON. You can see it as a really crazy JSON right here. It's just basically a whole bunch of JSON data. Someday I hope we'll be able to visualize it properly instead of just showing it like it's a broken wiki markup. And then use that JSON blob, which is nothing but the definition of all the countries, together with various additional sources. So for example, let's say I want to highlight individual countries. I would define a simple JSON parameter like this: BR, Brazil in pink, US in blue, China in red, whatever. You can put hex colors here. That's fine too. Now Vega accepts data in different format, something like this: ID. Let me make it bigger just in case it's not hard to see. ID country v color, ID country v color. So two parameter items. So the simplest thing I did was first to write a Lua module graph utils expand dictionary, which basically converts this format into that format. Once it does that, I pass the result of that invocation into the map. So this is the result of invocation, as you can see. And then if we look at the source of this map, it's not as complicated as it seems. Right there is the source of the invocation. It's actually fairly straightforward. The map itself, then this is the parameter right there, which expands the data, and an additional parameter just for the fun of it to make the map slightly smaller, otherwise it takes up the whole screen. And that generates this graph. Now, even more interesting graph is when you have very complex data. For example, here, I have a huge blob of data that I copied from UN, which is the world population by country history. So from 1950s up until 2010, I believe, yes, 2010, for each country. I recoded by country code, but initially it was done by country ID, which I think is actually better in the long run. And what I do with that is I wrote a couple of additional graph utilities, like parse CSV, which basically I say, okay, give me just the column to 2010. And this graph is basically the world population distribution per country of the 2010 data. And if I was to if I wanted to make a different data, like let's say a different year, oops, all I had to do was just change the number. Let's say 1950s, 1960s, and then it works. Show preview, and it works. And this is slightly different map. I mean, we should probably compare it side by side, but I mean, the difference is not, because this is growth, it's not going to be that pronounced, but let's just Hello. And there's, so as you can see, the colors are slightly different, but not that much, because in reality, the world population, like for example, this is slightly paler, this is slightly more pronounced, but in reality, you will need much more design work now to make these data stand out and be more usable than this. I'm not a designer, so I didn't even try. And this brings me to the conclusion of my little demo. And more time for questions. No, there is a question. I do not hear.
Can we make graph namespaces do template extension? Wouldn't that be the best of both worlds? That's a question from IRC.
Sorry, let me read it. I did not. Steph, where's the question?
It's, can we make graph namespace do template extensions? Wouldn't that be the best of both worlds?
We could, but then that means that if we wanted to wrap the graph in something else, like a small box around it, or put it on the right-hand side, or whatever, it would you would still use a regular template, which means half of your time you will invoke graphs, half of the time you will invoke templates, and you, as I said, there is no real benefit from the graph namespace. There is other than separating graphs from everything else, which doesn't really do much because, well, you can still use a graph tag. Plus, so there's really, from my experience, from everything I've used graphs for on Zero, there is really no benefit of actually having graph namespace. It confuses because it puts graphs in two different locations, but at the end of the day, you still use them as templates. So why not just have them as templates and maybe have a convention to call them something like template colon graph blah, and that solves it would look identical, and the only difference would be a small graph tag wrapping around it. There's a question in the room.
Yep, there's another question.
Yeah, hello. I wanted to know if Vega supports different kind of geographical projections, as in the one you have used is equirectangular, right? So
this one is Mercator, but it supports any kind of projections that D3 supports, because Vega is based on D3. So.
Okay. Yeah.
I think that's it for now.
Excellent. We're switching to Dan, and then we'll continue the presentation.
Hey guys, so I was going to walk through an example of writing a Vega graph from scratch, and graphs and pie charts are useful. I think the templating approach is really, really useful, and I love the stuff that Erie has, but there's another thing that you can do with this extension, which is really to tell a story. So that's what I want to do. I want to show you guys something maybe too ambitious, but let's see if it works. So are people here familiar with the Napoleon visualization? It's basically correlating 3 data sources and showing Napoleon's army going into Russia and what happened to them as a result. So basically on Labs, we installed this. I'm going to paste it into IRC and Hangout. Hold on.
Dan, you do realize I'm in Russia, right?
I realize you're in Russia. So this Lyra is a visual editor for Vega specifications. It's kind of beta quality right now. It's definitely wonky, and some things you have to do in a pretty specific order. But let's give it a shot. So we want to look at the army. There's some data sources provided here for convenience, but you can add your own. It's got a new data source thing. And it doesn't work very well with external URLs right now, but you can just paste in the values. We're going to want to look at cities. And we're going to look at temperatures. and cities. Okay, so Lyra has layouts. We're going to make an army layout. And we're going to start by, there's basically visual things on the top here that you drag down, transform them in some way with data, and kind of compose your graph that way. So we're going to first drag some text, and we're going to throw in the city. I'm dragging the city into the text property. So you see there's a bunch of like random text on top of each other there. And what we want to do is basically call this cities and distribute these things geographically. So I made a geographic projection, which is transforming the data. There's some things you're going to have to tinker with here. I'm going to leave these for later. I'm not going to explain too much. And basically, I'm going to take the latitude and longitude from the data source and put it in the projection. And what this does is it generates x and y coordinates that we can then use to drag and drop into the text. And you can see it got distributed in the x dimension, and it's going to get distributed in the y dimension. So these are basically our cities and plotted kind of geographically. So we're going to take this font, make it black. And we're going to put dots under them. So we're going to lift these up a little bit. Oh, and Moscow disappeared. We don't want that. So we're going to make this a little bit wider. And start a little lower. Okay. And now what we're going to do is we're going to add symbols, and we're going to map the city to the, sorry, we're going to, it has the same geographic projection, and we're going to take the x and y and distribute the labels next to the cities, turn it into circles, and make them a little bit smaller. So you can kind of see exactly where they are. And these aren't going to be offset. They're exactly at the geographic location. And let's rename that to cities. Let's rename that to city. And what we want to visualize is the army and the size of it going through these cities. So we're going to go to the army data, and we're going to transform that data and group it by the group in the army and the direction that they're going. So they're basically going to go into, march towards Moscow, and go back out. So we're going to add this transform to the pipeline and make windowed. We're going to window this to I1. And we're going to add a line. And this does something weird in Lyra. This is one of the wonky things. You have to erase this mapping. Don't worry too much. But basically, we're going to look at troop movement. And what we want to do here is also geographically transform this with the latitude and longitude from that data set, which is different because there's different data. So you can really see how you're correlating two totally different data sets here. And we're gonna have to replicate this sort of magical stuff that you get to by playing with it for a while. And it gives us an x and y again. So basically, we're going to plot. So there you go. That's the troop movement. And that's not very interesting. So why don't we make it thicker based on the army size? So we're going to make the thickness of the lines as they're moving into Moscow follow the size of the army. So we have the size property here, and we're going to drop it into the width. And we're going to make it a little bit different. We're going to make it from 1 to 50 instead of, so that it's a little more pronounced. And we're going to make it, instead of butts, we're going to round it off. So that's starting to look a little bit more like the actual visualization, but this color is a little weird. So why don't we take the direction of the army and transform the color going in and out of Russia. So what did I do? Oh yeah. So in here, let's pick something kind of more brownish, and let's pick something more blackish. Oh, I accidentally moved the color to the width, so let's take the size back. Okay. Pretty ugly color, but we're not going to worry about that right now. And the cities are underneath, so we can drag those and make them more visible by putting them on top. So there you go. Now you've got troop movement, and the thickness of the line is the size of the army. And you can see basically going into Russia, they started kind of really thinning out. And by the time they came back out, this black line shows them coming back out because it's mapped to the direction. They end up basically completely decimated. And what we want to show now is the temperature to kind of like get an idea of what was going on. So we're going to add a new layer. We're going to call this temperature. And let's make it a little bit wider and make it short. Okay, so it's going to show up down here. And basically what we want to do here is take the temperatures and plot some text. So we want the date as the text. And we also want to geographically position the dates. But we're going to do something a little bit different. We're going to transform here. We're going to add a formula. And we're going to just basically set 55 as a flat formula. It's a flat latitude. Because pretty much all the temperatures were measured around 55 degrees. So now we have a new field called lat, and we can use that as a static because we don't want it to oscillate up and down. But we can use the longitude from the data itself. And basically, same magic here. And we have x and y from the transform. And we're just going to put the x over here, so you can see the dates are spread out now. But for the y, we want to use the temperature. So we want to show the how cold it was, basically. And let's add a scale here. Well, let's turn them a little darker. And let's add a scale. So this is, and it's not a scale, an axis, sorry. So we're going to make a y-axis. We're going to take the scale that was generated for the temperature, and we're going to drop it into the axis. We're going to put it on the right side. That looks a little bit better, and we're going to offset it a little more. And we can play with how many ticks they show. So we can use just 4. And we can even put a little grid. So there you go. And let's plot the temperature as lines now. So we're going to drop the line in here. And we're going to call this temps. We have the geographic projection already set up, so we can take the x, and the y is going to be the temperature. We're going to make it, let's make it linear. And the text is kind of messed up. I don't like it over there, so I'm going to go back to the text and the dates, and I'm going to offset the y by 15 pixels. That way it's a little bit under the line. And there you go. that's basically Napoleon. The Napoleon visualization is pretty famous. It combines lots of different data into one kind of thing that you can, if you get familiar with it, you can really understand and appreciate kind of how much it's communicating. And the cool thing is, from Lyra, now basically I can export this data with inline values. And I can take this, paste it into my sandbox here, and check out the preview. And there you go. You can publish it directly to your wiki. So yeah, let me go back and ask if there's questions.
That was awesome.
Yeah. Yes.
So
yeah.
So Lyra is built on top of the Vega interactive thing, or is that just, what's the difference between lyra.wmflabs.org and this sort of Vega demo, interactive demo site that I think we have a link to?
Yeah, you're talking about, let me share back. You're talking about this editor here, right?
Yeah, the one you were in. How's that different from Vega Live editor?
This is the Vega Live editor you're talking about?
Yeah, can you explain what the two of them are for?
Yeah, so basically this, so Lyra is a bit wonky right now. If you could mute the room, sorry, it's echoey. So Lyra is just wonky. It does weird things. It generates random scales that you want to get rid of. I don't know if that came through, but I was doing things in a very specific order, because if you don't do them that way, it kind of messes up. The Vega editor is a lot harder to use, because you have to basically keep in your head the whole concept of transforming the data into the shape, but it's not going to have weird, it's not going to do stuff that you're not expecting. It's going to do exactly what you say in the specification here. So what they're both for different things. I mean, if you're trying to completely create something from scratch and you're pretty comfortable with the concept of basically how it works, I would use this. But if you're trying to learn something, I would look at the examples that are in Lyra. I would play around with stuff there, and then come back to this editor and compare the example. So based on what we just went through, you can see these magic values that I kept typing in here. These are the transformations for the geographic projection, and you can see that the temperature data set is using that transformation. So it'll be a lot more familiar to you if you start out in Lyra and come in here and kind of try to understand that way. Basically, I think in the long run, there's going to be more focus on stuff like Lyra and stuff like semantic editing and trying to get higher level away from Vega. But the fact that it exposes basically just blank canvas, whatever you want to do, is really powerful, I think, and can really let us do whatever we want. Yeah. You're muted still.
So can you go the other way? In other words, can I take any, if I see a graph and I want to tweak it, but I don't understand the JSON, can I paste that into Lyra and Lyra will sort of reverse engineer what it's doing?
They claim you can on their README, but I haven't been able to find a place in the interface. But it's open source, and people are, those guys are pretty friendly. So for example, just to give you an idea, the people who are working at Vega are University of Washington, and one of the research grad students there interviewed both Yuri and I yesterday and the other day to ask us how we would improve debugging Vega, and they're really involved and they really are putting a lot of effort into this. So yeah, I would recommend just checking out uwdata /Vega and /Lyra and filing issues with them or whatever you want. I'll paste them in IRC.
According to Vega people, they are trying to create a standard for sharing graphical information, and that's what they're trying to do with Vega. So eventually their idea is so that people don't share Excel documents with the graphs embedded in them, but share a definition of a graph with the data as a Vega format.
Okay, I don't see any other questions. Anything else?
I got tons more.
X has more questions.
I got tons more. So I mean, the really cool thing with this, I mean, people are generating graphs all the time, and I mean, generating tables of information all the time. And now there's a way to kind of just put the graph into a wiki page. And I know, like with Rachel's survey of the hackathon, you know, she got it from a Google survey, and then I realized, oh, you could put this in a graph. And then I think Yuri went and did a lot of work, or quite a lot of work, to transform it. So I wonder, you know, we should probably sort of encourage people to do something so that this is a lot easier to do. So rather than you know, coming up with Google Doc spreadsheets and then trying to get something else to graph them, just some sort of general, like, here's the steps so that you can have graphs of your cool stuff on the wiki show up. I don't know how we can make that easier. It sounds like.
I think
go ahead.
Yeah. Well, the first step that pretty much the communities have been asking me directly is come up with the templates. Show them like very simple templates how to do X, Y, and Z. Let's say they have a whole bunch of lines and they want to show them. Like, can we come up with like a prototype template that would do those lines, and then the community will modify it a little bit and make it more beautiful. But the initial template to do something is what the community needs the most. So if we can come up with a set of most generic graphs, that would be wonderful. Another thing that has been surfacing much more now than it ever was before is the fact that we cannot include templates cross-wiki. That's a huge complaint. And with the templates, it will become even more important, because with the templates, with the graphs, you want to have data uncommons, like, for example, statistics for the world population or GDP or whatever else information you want, or in Wikidata, but that's another story. And you want the graph itself also stored in commons, because you don't need 300 versions of the same template to draw a graph. So we definitely need to work harder to bring the shareable templates and shareable wiki pages, or embeddable wiki pages, and possibly modules, Lua modules as well.
Go ahead.
So what is this?
I want to make a little bit of a counterpoint. So I think while that stuff is going to make a lot of things really, really efficient, I think one of the coolest things here is you can look at a diff between someone changing a graph if it's the raw graph, not the template, and you can really start to understand how the changes to the JSON are changing the visualization. And so I think a lot of people are going to want to keep doing that. It sort of is a parallel kind of thing. That template work is important, but also raw graph stuff. It's going to stick around no matter what, but I think, yeah, not forgetting that that's also a separate cool use case.
Kevin has a question.
Yeah, so this looks really exciting. It's great. What is the status? Where is it released or deployed, or is there a timeline? What's
live? It's all live.
It's all
It's live on all Wikipedias.
There's a question on IRC from Guillaume. Has the communications team reached out to you about writing a blog post about all of this awesomeness? He thinks it really needs to be advertised.
Yes, they have. Heather is sitting right there in the back of the room. I can see her.
I saw someone making a wiki post about this. I'm not sure if that was the same person. Someone was trying to put graphs together to show how many signpost releases has there been through the years. and I'm trying to find the link right now. So there's some advertisement. Plus, there was something posted on Village Pumps in. I know it was posted in Russian. It was posted in English, and CA is, what is it? Caravan, I think, is actively working on graphs as well. Rachel, we can't hear you.
I said I'll keep you here all day asking questions. So about the raw data, can you? I mean, like for example, the Obama size changes data file. It looks like that's just a CSV file. Can you put just data files like that on Wiki Commons and have them work?
It's actually pretty sophisticated. It can handle pretty much any format: JSON, GeoJSON, TupoJSON, CSVs, TSVs, whatever you want. And you can put them as long as they're within Wikimedia domains. Is that correct, Yuri?
Well, that's the yes and no question. If you use the external URL, you can externally include any data source you want, but that data source has to be raw. In other words, you can say, oh, just take this action equals raw URL or API call and include it, and it can come from another domain. On the other hand, if you want something much more elaborate, which is a Lua invocation that Lua expands, then it has to be on the same domain. It has to be on the same wiki, because Lua cannot work with the, from what I know, cannot work with external data. So you're severely limited to what data you can get and in what format when you use external link, but you can get it from anywhere. Or you can use Lua to do any kind of data manipulations, but then it has to be local.
Ooh, I have a question for you, Yuri. So let's say I wanted to use an external file that gets updated every day, because then the graph would always be up to date, except it wouldn't be because Graphoid renders it. Is Graphoid doing rendering every day or every week or so?
Currently, it's rendering every 30 seconds. Because I just enabled caching just to avoid any kind of hotspot. Basically, if the graph gets placed on a very high visibility article, I don't want the Graphoid service to die. So it will update. But eventually, we need to decide how to handle this kind of external data scenario and how we want to do this. Whether we either can do something like the whole graph gets stored and hashed and stored in a separate storage, basically come up with a few extra SQL tables, or there has been some Fabricator bugs discussing this. Because at the end of the day, we run into similar problems with links and categories where graphs get out of sync, and there is a number of minor and edge issues that we need to resolve to figure this out. But yes, it is possible to make the data Graphoid re-render everything every couple of hours or something like that to be useful. Rachel, we can hear you.
Your examples of using external URL, they're both like CSV files, right? So I actually just updated. So the atoms count, somehow you created a CSV file containing those article edits. But I assume because our API can return JSON structures, presumably you might be able to get a graph to just actually query our API for something like that and somehow make sense of the JSON it returns, possibly via a Lua module, and then kind of directly render from the API.
That would be extremely cool. Currently, there is no way to insert Lua in between API, at least I haven't figured it out, a way to insert Lua between API call and graph. You can either call API directly from the graph and use the graph-only transformations, Or you can use Lua, but then Lua can only access static data stored in a wiki. Eventually, that's something I've been advocating for a while now. Lua should have access to the API to be able to do all sorts of very cool data extractions and visualizations.
Okay, and I guess the other thing is, I don't know if it's possible for depending on what the JSON structure returned by the API call is, maybe you could, it's sort of, I don't know if you can sort of get Vega to sort of understand, oh, this is the one piece of it you care about. I guess you'd have to look at every API call and see whether it sort of Vega can understand what the hell is in the data.
Actually, someone has done something like that, I believe, on Commons, drawing a pie chart, I believe, based on the API results. So it is possible. Someone has already tried doing that. I can try to find the link as well. And but you can do this already. It's just that you don't have all the power of Lua to process the data. Only the JavaScript, the limited JavaScript transformations that Vega has. Because don't forget, we had to severely restrict Vega for the security reasons, not be able to execute arbitrary JavaScript.
Anything else? Okay, I think that's it. Anything else, Dan, Yuri, before we finish up? Awesome, that was really cool. Thank you so much.
Thank you.